All right, what's up? Let's get on here to section 1.2, Venn diagrams. You've probably seen this in English class, maybe in a math class before. Basically, they're letting us create visuals for all these sets that we're talking about. So right now I've got a kind of generic Venn diagram with sets A and B. Okay? So first off, in the Venn diagram, so this is set A, but that's referring to this whole circle. Okay? Set B is referring to this whole circle, not just the little part over where the B is written, the whole circle. Okay, so you can see we talked about yesterday, an intersection, A intersect B, there's a visual of it where the two circles intersect, hence intersection. Down at the bottom I've got, what would A union B look like? Well, let's think about it. That means this is A or B or both. So Starbucks, cream or sugar or both. So one or the other or both. What part of the diagram is that? Well, that's just everything in the circle. So this would just be, so that, all of that. Okay, that's A union B. Notice outside here, A union B in parentheses, but we have the little complement. That's the part that's outside of the two circles. Okay? So let's take this a step farther here. I want to talk about how to draw these. That's going to be part of what this section is going to be. So I have A intersect B. So if I want to draw that down here, so I'm just going to call this A and B. And I write there to shade. You can shade. I've kind of actually started to use little check marks instead of shading, just because it's easier to see where I've put the check marks, and when I overlap, you'll see in a second here. So I'm going to put a little check mark everywhere A is. So that's part of A, and that's part of A. Okay, and then I'm going to put, so that's A intersect B, so I have A done. Now I'm going to do B. So I'm going to put a check mark for B, so there and there. All right, if it's intersection, it's everything that's shaded twice or checked twice. So the intersection, you can see that area right there. And obviously, you can tell that with two of them, it's easy, but when you start getting 3 and 4, and then it starts to get a little tricky. Let's start over. We look at the second example. A union B. So again, we'll shade A, we'll shade B, or put a check mark in each of them. So A is there and there. B is there and there. For a union, anything that has a check mark, that's the union. Right? That's what we saw on the last slide, all of those circles. Okay? So now, let's look at the next one. A union B complement. So that's everything outside of A and B. So that's the area out here if we wanted to shade it, or whatever, however you want to signify what it is. That's A union B complement. Okay, next one. A intersect B, but it's B complement. All right, so let's do the same thing. All right, let's use our rule. So I'm going to put everything, a check mark for all of A. So again, A, B. So A is there and there. Now we don't put a check mark for the B, we put a check mark for everything that's B complement. So every part of my diagram that's not in B. So where is not in B? Well, that part outside of the circles is not in B, as well as this part right there. Okay? Since it's intersection, it's everything that's shaded twice or checked twice. So A intersect B complement is this area over here. You notice I wrote the little half moon shape of A. If we flip that the other way, but I want A complement intersect B, check everything that's A complement. So everything that's not in A. So there, and then that's A complement. And then B, check everything in B, there, and there. Since it was intersection, it's everything that was checked twice. So now it's that little half moon on the other side. Okay? So when you have two things intersecting, but one of them is a complement, it's going to look it's going to be a little half moon shape. Another thing you might get looks similar. Let's say I want a union B complement. Okay, so let's go through our rule. Let's check everything that's in A. So A is there and there. B complement, there and there. But with union, if we look right up here, union is everything that's got a check mark. So that's outside, here, and here. So now it's everything except the little half moon shape. So it's all this, all that. Okay, everything except that little half moon shape. So if you follow the rule, you just, whatever the letters are, so you have A, B complement, put checks in all those. And then union is everything that's got a check. Intersection, everything is checked twice. All right. Follow that rule, and you're going to be good to go with most all of the Venn diagrams you're ever going to do. All right, here's what it looks like for 3 sets. Obviously, a little more complicated. All right, but you can go through the same rule if you want. So say I wanted to find, let's just say, A intersect B intersect C. So that part there. So what we would do is I would put a check mark everywhere in A. So there. Put a check mark, so that's the A part. So the B, put a check mark everywhere in B. And then for the C, put a check mark everywhere in C. So now if we look, well, it's going to be, not everything is shaded twice, but now since there's 3 sets, everything is shaded 3 times. So that is that area there. Okay? And you can do it with any of these sets. Okay, if I wanted to find this one maybe. Okay, A complement, I check everything not in A. We can look at that real quick here. So everything not in A for A complement, there. Everything not in B, so there. Everything in C, there. Since there's 3 sets all intersecting there, so we have 3 checks. You can see it's this little part. It's kind of similar to where I only had the 2 sets. It's that little section that's only C. Okay. All right, just some helpful rules and then another couple definitions here at the end. These are going to be helpful to know. And actually, it's easier if you just kind of memorize them if you can. So if I have A union B and I want the complement, that's the same as if I have A complement intersect B complement. Notice the differences there. All right. If I flip that, I have A intersect B, but I have the complement of that. Notice how that changes. That's A complement union B complement. All right, you can look at that back in the last, or just on a Venn diagram, draw it out, and you'll see it. All right. A couple definitions. We talk about pairwise disjoint. Okay, that means every pair of sets in a collection do not intersect. Okay, so if I have a bunch of different sets in a collection, they don't intersect each other. Okay, in other words, no pairs of sets have anything in common. So all of our circles are separated, basically. Okay, a partition uses that definition. This is the more important one, really, to understand. A partition of a set is a collection of non-empty subsets of X, which are pairwise disjoint. And whose union is the entire set X. All right. So let's simplify this a little bit. Let's just say I have a set right down here. Set X, just the numbers 1 through 9. All right. So if I break that into subsets, all right, so I just made 3 subsets, okay, X1, X2, X3. Take a look at those. None of them intersect, right? Each subset is pairwise disjoint because there's no 4 and 5 in this one. There's no 1, 2, 3. Okay, there's no overlap in any of them. They don't have anything in common. Okay, and if I put them all together, the union, that's just putting them all together, one or the other or both. The union gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, the entire set. If that happens, that's a partition. Okay, so no overlap. You put them all together, gives you the entire set. And then down here, partition principle says if I have a set X that's partitioned into subsets, in this case 3 subsets, but it would be the same no matter how many subsets you have, the number of elements in X is equal to the number of elements in each of the subsets put together, each of the partitions put together. Okay. So if you notice up here, there were 9 elements here in set X. All right, the subsets, that one had 3, 2, and 4. To put them all together, that's 9. Okay. You could have partitions of 5 or 6 or 7 sets, whatever you want. Okay. So let's say I did, maybe this wasn't there. I say X sub 4 is 9. Still a partition. Everything still works out. Okay. Okay, so next section will be about the sizes of sets. So we have some more topics. We'll get into that next week.